Anybody know?
You're going to talk through the network.
Only way you're going to talk is through the network. If you have a box sitting here and a box sitting there, how do you talk to them? How do you have them communicate? Via the network. That's the way the hypervisor works as well. That was one of the security goals, because we're on the security goal slide of the communication. What's the problem with that? What are some features that you'd like to have? Since they're on the same machine, why not just let them communicate? Create more channels for them to communicate. It's easy to do, right? What's the problem with that? Security is a big problem for that. Because you know, this is the thing. The more doors you create, the more locks you've got to put on those doors. And the more doors you create, the harder it is to lock all those doors. And more importantly, the harder it is to know where all those doors are to lock. So let me give you an example of a really cool thing to have in Hypervisor that you don't have because of this. How about drag and drop? Take a document off my desktop and just drag it into a VM. I mean, that'd be kind of cool if I was on the parent partition, right? If I was logged into the parent. But that would create another door that we had to give you a key for, right? That we'd have to be able to lock down, and more management, harder for you, and harder for you means ultimately less secure. Hypervisor, whenever it was designed, the goal is all about security. So Hyper-V and SDL. Hypervisor was built with StackGuard cookies. So this is what they did to make sure they achieved those goals. Okay? Address space layout randomization. So ASLR. Basically what that means is your guest VM isn't always going to have the same blocks of memory. It gets handed out randomly different blocks of memory, and that's what it uses. And what it actually does is once that memory is freed, it's not just left there for chance of somebody else is going to look at it the next time they get that block of memory and see if they can pull something out of there. That memory's got to be wiped before it can be reused somewhere else or anywhere else, everywhere else. Okay? But again, the memory management, that's one of the reasons why that's done at a really low level, at a really fast level. All that's managed by the hypervisor. Hardware data execution prevention. Okay, this was a big one when it first came out. Okay? Why in the world do I have to have hardware virtualization in my virtualization stack? Okay? That was one of the things that gave us is a huge performance boost and also the security of that data execution prevention. So that is the no execute on AMD or the execute disable on the Intel chip. So those were a requirement. Code pages are marked read only. Memory guard pages, we talked a little bit about that. Hypervisor binary is signed. Okay, what does that mean and why do I care? Well, by having the binary signed, that means if somebody tries to tweak the hypervisor so the next time you reboot it, it now is running foreign code. Whenever hypervisor boots, it checks its own signature to make sure that it hasn't been tampered with. All right? So if anything's tampered with it, guess what? It's not going to fire up.
Blue screen death?
I'm not actually sure what you would get, but you probably would get a blue screen because the hypervisor won't load. That's probably exactly what would happen. You get a blue screen, and it would give you some message saying that the hypervisor was invalid, or an invalid signature on the hypervisor, something like that. Absolutely. But you would know, and more importantly, your data, your machines would be protected, right? Okay.
I'm just curious. How is the signature checked? How can that not be spoofed? How can that be protected from spoofing? Does it require a connection to a root certificate?
No, it's actually a hash. It checks it against its own hash.
Okay.
So it checks the binaries against a hash, which anybody that does hashes knows you can't really trick a hash. Yeah.
Would this be the same circumstance if you had a memory fault? Would it see that as a bad build or something?
Well, the bits are actually stored on disk when it loads. So it's checking the bits that are loaded, not necessarily what's in memory. If you have, so you'd probably get a blue screen if you had a problem with memory, but it would be a different situation. Yep.
But if it was, it could be sensitive to hardware failures.
Sorry?
It could be sensitive to hardware failures. But the signature.
Yes, the signature would absolutely be contingent on hardware. So if you had a hardware failure, say you have a disk, bad spot on the disk, absolutely your hypervisor is not going to run. And it might even give you a bogus error, like it won't tell you that you have a bad block, but it'll tell you that your hypervisor is invalid, or something like that. Yeah, you'd get the blue screen. So what is SDL?
Is it just the hypervisor that's signed, or all those other parts that are running the parent, are those signed also?
The hypervisor signed.
Okay.
Hypervisor signed. Yep. What is SDL? Software Development Lifecycle, right? I can have a hard time with that. Those guys that are developers, it kind of comes natural. I used to be one, but that was a long time ago. The software development lifecycle, you go through, in order to go through that entire lifecycle, you go through things like threat modeling, static analysis, fuzz testing, penetration testing. The entire lifecycle of the application development process was completed on the product, on the project. And it has gone through some very, very, very rigorous testing. And it's used by all kinds of companies, you know, finance companies, governments, even military. Hypervisor has passed just about every test that's been thrown its way. There are some companies, I'll be straight with you, there's some companies that I've heard of that won't use it because they're afraid of security. Now, ironically...
What is fuzz testing?
What's fuzz testing? Who's my programmers in here? I'm not going to answer because I'll give you a slightly variated answer from the truth. But it's stuff that developers do to make sure that everything is going to work the same every time. And it's going to work the same every time. But it's all stuff that the coders have to do as it goes through the testing and the validation process to make sure that there's no issues. Okay? Now the ironic thing is, if you look, how can I say this? I really can't say this, so I'm just going to shut up and say there are some companies that don't use the hypervisor, but it's not because it's not secure, it's because of their own lack of trust in the environment because of, for whatever reason. You know, either they don't know, or they heard, or whatever, I don't know. Has anybody heard of bad things about the hypervisor? I'm curious, I want to know, and I didn't pre-stage this question with anybody. Has anybody heard of vulnerabilities with hypervisor or problems with security in hypervisor? Anybody? Anything? Nobody. You guys are a pretty smart crowd. I mean, this is the virtualization user group, right? You guys know virtualization? Are you? Who's the first time here? One person? Okay. You guys have been around for a while. Yeah, I mean, the vulnerabilities on hypervisor just aren't out there. It's a secure platform, so it's not something we worry about. So the Hyper-V security model. There were some questions about AD. I think this is where that's going to come up, this slide or the next one. Yeah, this slide. All right. So it uses Authorization Manager, ASMAN, fine-grained authorization and access control, department and role-based, segment, who can manage groups of VMs. So you can have different types of management of your different virtual machines. You can define specific functions for individual users or roles. So if you're going through the Authorization Manager, you can decide on this machine or on this server, you can allow this user to start or stop these machines. You have that granular capability from the hypervisor components to actually drive that and actually allow that to happen. So adding hardware, changing drive images, stuff like that. So changing a CD, you could give somebody permissions to, but not necessarily give them permission to stop or start or restart a machine. If you guys got all that. VM administrators don't have to be Server 2008 administrators. Okay, so you can delegate these permissions without giving up the keys to the farm, if you will. So the delegation is kind of cool. Guest resources are controlled per VM configuration files. So again, with the Authorization Manager, each VM has its own configuration file. Each VM can have its own set of managers and its own set of rights per manager. Shared resources are protected. So like read-only, the CD is an ISO file. That's a read-only or protected resource. Copy on write for differencing disks. So you have all that built into the security model. BitLocker. Okay, now again, remember the topic. It's Hyper-V security. How do I make sure that my hypervisor is absolutely secure? 100%.